Let's begin the notes on Chapter 9 and 10. We're actually going to start Chapter 10 first. If you look in the Chapter 10 notes at the end, there's a chart, and it's your responsibility for filling out that chart. Now, how are you going to find the answers for that chart? In your textbook, in Chapter 10, there are numerous charts that list individual muscles, where their origin is, that's where the beginning part is of the muscle, where the insertion is, that's where it hooks to a movable bone, and the action of each muscle. If you remember at the end of Chapter 8, talking about joints, we went over different kinds of movements like flexion, extension, abduction, adduction. And so on the chart you'll see the resulting action from the contraction of the different muscles. Looking on the screen right now, these are the muscles that you have been assigned, and for these muscles you need to know their general location in the body. You need to know their origin, that's where they attach to the stationary bone, their insertion, that's where they attach to the movable bone, and their action. And so just let me give you an example before we look at the chart. For example, on the test, I might say originates at the ilium, the sacrum, the coccyx, and inserts at the gluteal tuberosity to extend the thigh. So that means that it begins at the top of the fan part of the hip bone, at the sacrum, which is the vertebrae that's between the hip bones, the coccyx, which is the tailbone, so that tells you you're on the back side of the body. It inserts into the gluteal tuberosity, so that's a roughened place on the femur where what muscle attaches? The gluteus maximus. So that one really is a no-brainer, because if you knew gluteal tuberosity was on the femur, then you know that's where the gluteus maximus attaches, and the action of that muscle is to extend the thigh. Let's look at another example. Another muscle originates at the clavicle, the acromion process, and the scapular spine. So that means that it attaches to the collarbone or clavicle. The acromion process, you know, that's the little part that the clavicle sits on. It's an extension of the shoulder blade. And then the scapular spine, which is on the back. And it says that it inserts at the deltoid tuberosity, and it abducts the arm and is important in arm swinging. So again, this is kind of a no-brainer, because the deltoid tuberosity is a roughened place on the humerus where what muscle attaches? The deltoid. So let's look at one that's not so easy. This one originates at the external occipital protuberance. Remember, that's the bump on the back of your head. And then spinous processes of the vertebrae. So you think about it originates at the back of your head, and then on the spinous processes of some vertebrae. It inserts at the clavicle, the acromion and spine of the scapula, and it elevates and depresses the scapula. It elevates and depresses the scapula. That means that you can shrug your shoulders and let them go down. Just do that a couple times. Where do you feel it pulling? Well, I feel it pulling in the upper part of my back, which would be the trapezius muscle. Which muscle originates at the ischial tuberosity, the linea aspera, and inserts at the fibular head and the condyle of the tibia to flex the leg at the knee and laterally rotate the leg when the knee is flexed? So ischial tuberosity, that must be a roughened place on the ischium, so that's kind of where you sit on that hip bone. And then it's the linea aspera. Remember that that's kind of a line that's under the gluteal tuberosity that goes down. It inserts at the fibular head, so that would be the little bone, the lower leg. And then the condyle of the tibia, that would be the proximal end of the tibia. So we have something running from your hip down the back of the femur and attaching to the tibia and fibula, and it's going to flex the leg at the knee. Well, I know that most people know that the biceps brachii plays a role in flexing the arm. So what muscle do you think is going to play a role in flexing the leg if it's found on the femur, and it's going to have two heads, and it's going to flex like the arm was flexed, but it's going to flex the leg? So it would be the biceps femoris. So this is the chart that I was talking about. So what you need to do is look in your book, or if you go on My Labs Plus on the study area, and then look on the left-hand side where it says A&P Flicks, and once you get into the A&P Flicks, there are flicks about origin, insertion, and action, and you can select the muscles I've assigned to you and actually watch a picture of the muscle working, and they tell you where it inserts and where it originates. Now, when I filled out the chart, I filled it out according to my background, or words and places in the body that I knew. And so if I filled out this chart, it really wouldn't do any good for you, because I know some words that you don't know. So you need to read and listen about the locations and the origins and the insertions, and fill them in according to what you know, what you learned in the previous chapters. You may have to write more than I had to write. Don't write everything down. Just give yourself a good idea of where this muscle starts or originates, where it inserts, or the movable bone that it attaches to, and then its action. Now notice on the hamstrings, there are 3 muscles that make up your hamstrings. The biceps femoris that we just talked about a while ago, the semitendinosus, and the semimembranous. I want you to focus with the location, origin, insertion, and action on the biceps femoris, but I want you to know that these are the 3 muscles that make up the hamstrings, those that are found on the posterior thigh. Just like I want you to know the hamstrings, I want you to know the 4 muscles that make up the quadriceps as well. We're going to focus with our location, origin, insertion, and action on the rectus femoris, but I want you to know that the vastus lateralis, the vastus medialis, and the vastus intermedius are all together known as the quadriceps, those muscles that are found on the front of the thigh. So you fill out this chart, and you learn to identify muscles if you're given the action or the insertion and the origin. This is a picture of a chart in the book, and you can see like latissimus dorsi. It's a broad, flat, triangular muscle of the lower back. It originates. You probably don't know what the lumbodorsal fascia is, but you know the spines of the lower 6 thoracic vertebrae, lumbar vertebrae, 3 to 4 ribs, and iliac crest. It spirals around the teres major to insert in the floor of the intertrabecular sulcus. Well, you know intertrabecular sulcus of the humerus, so you might just write that. And the action, it's the prime mover of arm extension. It's a powerful arm abductor. And then if you read on down, it says it's important in a power stroke like hammering or swimming or rowing. That might be something that you can write so you can remember it. So use the charts in your book to fill out the chart I gave you. And here I'm giving you more. And then you can use that study area as well. So now let's begin the notes on Chapter 10. Chapter 10 is not in an outline form. This is a bunch of information that's important in knowing how skeletal muscles work as groups, and to understand something about the way they're named and the shapes of the muscles. So this is general information about the skeletal muscles. After we get through with Chapter 10, then we'll go back to Chapter 9, focusing on the macroscopic and microscopic structure of an individual muscle and how it functions. So let's look at this first note sheet. The arrangement of the body muscles permits them to work together, either together or in opposition, to achieve a wide variety of movements. Remember that muscles only pull, they never push. I was trying to see if my movie would work, but it won't. I actually got this movie from those actions, insertions, and origins on the A&P Flicks on My Labs Plus. So this one is the flexing of the arm, so if you want to see it. But if this arm would flex, we would see the lower arm go up towards the upper arm. And so the muscles that are on the anterior surface of the arm would pull the lower arm up when we flex the arm, and then the muscles on the back of the arm would pull to extend the arm back down. So muscle groups only pull, they never push. And usually what one muscle group does, another muscle group undoes. Like the anterior muscles would flex your arm, the posterior muscles would extend your arm. Generally, as a muscle shortens, its insertion moves towards its origin. Again, looking at this biceps brachii, it inserts up at the scapula, it originates up at the scapula and it inserts down there on the radius. And so when that muscle contracts, the insertion end is moving towards the origin end. So, the definition of those two words, insertion and origin: the insertion is the end of the muscle that attaches to the movable bone, while the origin is the end that attaches to the immovable or fixed point. Now again, my muscle movie is probably not going to work, but if it did, you would see that the origin or the fixed position of this muscle is here. It's proximal, and the insertion, where it's inserting into the radius, the movable end, if you flexed your arm, is attached where the arrow is pointing. The insertion is to the movable end. So if we could flex this arm, we would see the insertion end move towards the origin. Now, normally in any muscle movement, there are four basic functional groups of muscles. The muscle that actually does the main movement, for example, when we flex our arm, we like to say the bicep brachii does that, but mostly the prime mover or the agonist is the brachialis muscle. It provides the major force for that movement. Now, we know on the opposite side of the forearm, there's a group of muscles that the triceps brachii is part of, and if it contracts, it can extend the arm down. So a muscle that does the opposite action of our prime mover, the one that's relaxing while our prime mover is contracting, is considered the antagonistic muscle. So it says the antagonistic muscle can produce the opposite movement, but is relaxed when the prime mover is contracted. Usually the prime mover and the antagonistic muscle are on opposite sides. So we know our brachialis and our biceps brachii are on the front part of our arm, and it causes us to flex our arm. And while we're flexing, the triceps brachii is the antagonistic muscle, and it's relaxing. Now, that doesn't mean that the brachialis is always going to be the prime mover, because if I extend my forearm back down, now my triceps brachii is going to be the prime mover, and my brachialis and bicep is going to be the antagonistic muscle. They'll relax while the tricep brachii contracts. Now, there are two more jobs. Some of the muscles that are there just help the prime movers. That's really what the biceps brachii does. It helps the brachialis muscle. It adds extra force to the movement, and it reduces undesirable and unnecessary movement. So you have a nice smooth contraction, and your brachialis doesn't contract and your fist come up and hit you in the face. So it gives us a nice smooth movement. These muscles that assist are called synergist muscles. Now also, if you can imagine, when you go to flex your arm, that origin has to stay still. If there weren't muscles holding your shoulder steady, then your shoulder would fall forward. So any muscle that immobilizes the origin or the bone that's staying still is called a fixator muscle. So a fixator actually is a synergist because it helps, but it helps specifically by immobilizing a bone or the muscle's origin. Now, the role of muscles can change, and I gave you the example of the biceps and the triceps and flexing and extending. There is a movie on My Labs Plus that actually shows you how the roles can change from prime mover to antagonistic muscle, and so I hope you view those. So how do we name skeletal muscles? If you understand the naming, maybe identifying where muscles are and what they do will be easier. Sometimes we name a muscle because of its location. For example, take the intercostal muscles. Costal has to do with the cartilage around the ribs, so the intercostal muscles tell us that it's found between the ribs. The biceps femoris tells us that it's on the femur. Biceps brachii, brachium is the upper arm. Rectus abdominis tells us it's dealing with the abdomen. So sometimes we name muscles according to the location. Sometimes we name muscles according to the shape of the muscles. Your shoulder muscle, your big deltoid muscle, is a triangle. If you know somebody that's in a fraternity that has delta as part of the title, you know that one of the symbols is a triangle. A trapezoid is a rectangle that's slanted, and if you think about the big trapezius muscle on the upper back, it looks like a kite or a trapezoid, so hence they named it trapezius. Sometimes we name a muscle because of its relative size. The gluteus maximus is a lot larger than the gluteus minimus or minimus. So sometimes we name it according to its size. There is the adductor longus, and it's a very long, skinny muscle. Sometimes we name muscle because of the direction of the muscle fibers. The word rectus means straight up and down or parallel to the axis, so your rectus abdominis is running right up the midline of your abdomen. Oblique, if you remember from chapter 1, means at an angle, so your external obliques are running at an angle on the side of your torso, on the front. Another way we name muscles is by the number of origins. How many origins do you think the biceps brachii has? It has 2 origins, so that head at the origin end, at the end that hooks to the stationary bone, actually is split, so it actually attaches in 2 places for better strength. The triceps brachii, the head is going to split into 3 pieces for attachments. How many attachments do you think the quadricep muscle has? When we learned that a while ago, it has actually 4 muscle groups, so it has 4 heads. Sometimes we name a muscle by the location of the attachment, by the origin and the insertion. Sternohyoid, where do you think that's located? Well, it goes from the sternum to the hyoid bone. How about the xiphi humerales? The xiphoid process, it runs from the xiphoid process, which is that bottom part of the sternum, up to the humerus bone. So sometimes you can look at the name of the muscle and tell where the origin and the insertion are. And the last way to name muscles is by the action. Some muscles are flexors, some muscles are extensors, some are adductors, abductors, so they use the action in naming the muscle. Let me give you an example of a muscle where we use several of the 7 categories. The extensor carpi radialis longus. Well, what do we know about that muscle? It's not one of our assigned muscles. Well, we know it extends something, so that means that it's going to put some part of the body back into its anatomical position. Where are your carpals? The carpi, that would be your wrist. The radialis, radius is the bone that's hooked to the thumb, and longus. So this must run across or from the carpals to the radius, and maybe it helps to extend the hand at the wrist, and it's a very long, skinny muscle. So just by looking at the name, even if you'd never heard of that muscle before, you know something about where it is and what it does. How about the depressor labial inferioris? Well, your labia are your lips, and inferior must mean your bottom lip, and if you depress, you bring towards the inferior, so if you pout, you are using your depressor labial inferioris. Now let's move on to muscle mechanics. You can tell something about how a muscle works by looking at how the muscle cells or the muscle fibers are arranged in that big muscle group. In the next chapter, in chapter 9, we're going to learn that if you take a big muscle, you can break that muscle down into individual bundles of muscle fibers called fascicles, and then the fibers into smaller parts, myofibrils and myofilaments. So your muscles are made up of muscle cells called muscle fibers, and muscle fibers are arranged in bundles called fascicles, You put all the fascicles together and you have your whole muscle. So if you look at how those fascicles or bundles are running in the muscle, you can tell something about the way it works, whether it's going to contract and give a lot of movement or whether it's going to contract just a little bit and give a powerful movement. So let's look at some of the common arrangements of fascicles. If the fascicle runs in concentric circles, like the image that just came up there, a concentric circle is one circle on another, that arrangement is called a circular fascicle arrangement, and you find that around your mouth, the orbicularis oris, or around your eyes, the orbicularis oculi, or sometimes in smooth muscle in the organs of like the digestive tract, the muscles are running in concentric circles and can be sphincter muscles or valves. Another fascicle arrangement, it has a broad origin and the fascicles converge towards a single tendon. So since they're converging, like the pectoralis major muscle, it all converges, it fans into that one spot. It's called a convergent fascicle arrangement. Another arrangement is where the fascicles run on a long axis. They're parallel, is like a big strap. And that would be like the sartorius muscle that goes across your thigh in the front. That's a parallel arrangement of fascicles. But that enables you to cross your leg. So it's running like a long strap. They're running parallel to each other. Most of the muscles, like the biceps and the triceps that you're familiar with, this would be the biceps brachii, is fat in the middle and then it spindles out or it gets slender on the end. This is called a fusiform arrangement of a muscle. Another arrangement that we see is like half of a feather. The fascicles are short. One side runs oblique to a central tendon that runs the length of the muscle. So the tendon would be like the quill in the middle of a feather, but this is only half a feather. And so this would be a pinnate, and the muscle down in your calf or in your lower leg in the front would be an example of a pinnate muscle. If we put two of those pinnates together, a prefix for two would be bi, so we have a bipinnate situation, and this is your complete feather. The fascicles insert into a tendon from opposite sides, and an example of that kind of arrangement can be seen in the quadricep muscle. And then if we put several feathers together, then we have multipinnate, and that would be like your deltoid muscle. Deltoid muscle. Look how it looks like a triangle. So this is a picture that shows all the different examples of the arrangements of fascicles. And notice that the long parallel shorten the most, but they're not very powerful. And the stocky, bi, and multipinnate shorten very little, but they are the ones that give us the most powerful force. So one more bit of information about the mechanics of the whole muscle. When we look at muscle movement, we're looking at the muscle pulling bone mostly. Sometimes it's pulling skin, like with facial expressions, but most of the time it's moving a bone. And so when you look at the muscle and the bone working together across a joint, that's considered a lever system. You might remember simple machines from a physical science class or a physics class that you've taken. And so you might remember that a lever is considered a rigid bar that moves on a fixed point or a fulcrum when a force is applied. The force is the effort, and it's used to move a resistance or a load. Like the jack is a lever system. Also, the shovel is a lever system. Notice that there is a place for the load, and there's a place for the effort or the force to be exerted, and a place that we're pivoting on, or the fulcrum. Well, when you think about the way your muscles and your bones work together across a joint, they're actually a lever system. The fulcrums in this body lever system are the joints. That's where we're pivoting on. The levers or the loads are actually the bones, and the muscles provide the force or the effort. So when we look at the lever systems, when we put the bones and the muscles and the joints together to look at our movements, there are three types of lever systems in the body. The first class lever system has the fulcrum in the middle. Look at the examples. A teeter-totter is a classic example of the first class lever system, where the fulcrum is in the middle and the load and the effort are on the opposite sides. Scissors are also a good example of this first class lever system. In your body, an example would be when you hyperextend your head. The muscles of your back of your neck are going to pull your head backward, and pivoting on the atlas and the condylar process is going to go back and forth. So that's going to be the fulcrum point, where the spinal cord hits the skull, or the occipital bone of the skull, and the load is going to be the whole front of the skull. So I mean, we can hyperextend, and actually we can flex our head and go back the other way. So the load is on one side, the effort's on the other side, and the fulcrum is in the middle. An example would be hyperextending your head, a seesaw, or scissors. Let's look at a second class lever system. With a second class lever system, the fulcrum is on the end and the load is in the middle this time. So if you think about a wheelbarrow, you're going to pick up on the handles, so you're going to be the force or the effort. The load's going to be in the middle and the fulcrum's going to be on the end. If you stand up on your tippy toes, this would be an example of a second class lever. The fulcrum would be your toes. The load, you're picking up your foot, your heel, and it's that gastrocnemius muscle of the back calf that actually is giving you the force or the effort to do that. So an example is plantar flexion. Another example is a wheelbarrow. So effort, load, and then fulcrum. Probably the most common type in the body is the third class lever system, and this is where you have the load, then the effort, and then the fulcrum. An example would be flexing the antebrachium, tweezers, or fishing. Now, you might be thinking, I don't think so, Mrs. Anderson, because if you look at that picture of that muscle, it looks to me like the muscle's on one side, the fulcrum's in the middle, and the load, the barbell in the hand, is on the other side. But look again at that muscle. Where does that muscle attach? It attaches to the radius. So it's on the distal side of that joint. So the joint is proximal, and then the effort is a little more distal, and the load is the most distal. So the effort is actually between the fulcrum and the load. Just like when you're fishing, the one hand you're holding the pole steady in is the fulcrum, and then you grab up further up on the fishing rod, and that's where you exert your effort or your muscle action, and of course your fish is your load. Third class lever system. Load, effort, and then the fulcrum. So that gets us out of Chapter 10 and into Chapter 9. And so I'm going to take a little break here and come back with the second video with Chapter 9.